assistant professor in LGIT. Student, welcome to session number 6 of chapter area and volume. You know that in a previous session I have explained about how to find the volume from different using the different formula. Now in this session I have explained one example of find the volume of earthwork, and I have covered a topic of capacity of reservoir, means find the capacity of the reservoir. I have already explained in a previous session there are major two elements are there in particular volume session. One is find the volume of earthwork, and second find the capacity of the reservoir. So now I will repeat this term, explain the repeat this term so you clearly understand. First, there are two equations are there for finding the volume. One is a volume of trapezoidal rule. I have already explained in detail with example. Previous session was just particularly you have remembered that. So that's why I have put this slide. So computation of volume trapezoidal rule, you know that V equal to D by 2. First area cross section area of last cross section plus 2 in bracket sum of remaining cross section area. Similar that volume of prismodial formula, volume equal to D by 3, first cross section area plus last cross section area plus 4 in bracket sum of even cross section area plus 2 in bracket sum of odd cross section area. So these two equation is important for finding the volume of earthwork as well as the capacity of the reservoir. Now this note is important. So the prismodial formula is applicable when there are odd number of sections. In a previous example, I have explained the height or area of cross section is given 7. So it is an odd number of section. So these are a limitation of prismodial formula. It is the applicable when there are odd number of section are there. But when in an example the number of section are given in an even form, so the end section is treated separately and their area is calculated according to the trapezoidal rule, and then both the result are added to obtain the total volume. So then when in an example you have given 10 number of ordinates, means 10 number of heights, means even number 6, 10, 4, 12. So this time you have find the one, like I have given one example like 10 cross section are given. So 1 to 9 cross section area means volume you have find from prismodial rule, but last 9 and 10 area of cross section we will find the using the trapezoidal. So I have already explained in a Simpson rule in an area section, but here not a single example asked in GTU from this type, but you have remembered this now. Now here new concept is prismodial correction. Why prismodial correction to be necessary? Because prismodial rule gives the correct volume directly, means prismodial rule gives the correct volume, but trapezoidal rule does not give the correct volume. So which are, what is the difference of them, and which type of error to be developed? So we have find the prismodial correction, which amount of the error to be developed. So that's why you have find the prismodial correction. So prismodial correction Cp equal to volume by prismodial formula minus volume by trapezoidal rule. So why this formula to be used? Because prismodial rule is give the correct volume, but trapezoidal rule is not given a correct volume. It is a given the approximate volume. So that's why you have find the correction. So you have remembered this equation. Now I give one example. This is a most important example for GTU. So you have, and this is an example only not for a GTU, but for a finding the earthwork of the particular road section. So this is the most important. So first derive the prismodial formula for compute the volume. So first you have write the prismodial formula, then start the example. A highway embankment 200 meter long is 12 meter wide. The formation level and has the side slope, two horizontal to one vertical. The ground level at every 50 meter along the center line are as under. Distance is given and RL means reduced level is given. Distance up to the 50 meter. So distance 0, 50, 100, 150 and 200 because our road highway embankment is 200 meter long. RL is given at a zero distance. Reduced level is 104.8. Reduced level you have you know that already you have explained in a you have already studied in a basic civil engineering subject. You have considered that now till you have considered that the height at zero distance of embankment means ground level is 104.8. At a distance 50 meter, rising of the height is 106.2. So his RL is 106.2. Similar that give the in an example up to RL up to 200 meter distance. Now the formation level at zero change is 107.0 meter. Means your ground level is up to 104.8, but your work at start at formation level, so its RL is given by surveyor or designer is 107.0. This change means this RL is given by the particularly surveyor or observer. Okay, so my work is start from the formation level and my formation level at zero distance is 107.0 and embankment has rising gradient 1 in 100. So it means uh, when you have I have given a simple example. I have start the walking 0 to 100 meter. So when you have starting 0 to 100, so your vertical slope rising 1. Then next 100 to 200, so your rising gradient is means your vertical slope is rising as a in a 1. So you have walked the 100 meter distance and your vertical slope is rising 1. So is meaning of that embankment has rising gradient of 1 in 100. So when you are starting 0 to 100, so a rising gradient is a 1. The ground at a level across the center line means it is a given level section example. Calculate the volume of earthwork by Prismodial formula. So you have find the volume of the earth. Here you have this is an example very important. So clearly attention student, I have make the figure so you have clearly understand. First step, you know that given which data is given, you have writing in this form level section because ground is level along the transverse direction. Width is given, road width is a 12 meter. S horizontal to 1 vertical, so 2 is a horizontal, so S equal to 2. Interval is a 50 meter. Rising gradient of 100 gradient of 1 in 100. The formation level at zero change is 107.0 meter. Now I have explained in a longitudinal section, means I have draw the horizontal section, so you have clearly understand. So how to find the volume? So first I have taken road distance. You know that the road width is a 200 meter. Sorry, length is a 200 meter, and every 50 meter RL is changed, reduced level is changed. Ground level is given at a zero distance. Here you have considered a 8, not a 0. I have mistakenly written here. You have considered 104.8. So now uh, these are length of the road 0, 50, 100, 150 and 200. Interval is given. Now you have only you have focused the ground level at a zero distance. Ground level is 104.8. So at a zero distance your ground level is 104.8. At a 50 meter distance your ground level is 106.2. Similar that up to 200 your ground level is 108.3, already given in an example. Here clearly seen, clearly in an example. So first you have established the ground level. Now you know that your work is starting from the formation level. So now your formation level at zero change already given the formation level at a zero change is 107. So here at a zero change means zero distance starting 107.0. Okay. Now the embankment has a rising gradient 1 in 100, meaning that when you have starting from 0 to 100, 100 are there. So one slope, vertical slope is rising. So here answer 107 of the 0. So you have add plus 1. So your level at formation level, sorry, your uh, for at a distance of 100, your formation level is 108. Because why 108? Because rising the gradient 1 in 100, you have starting from 0 to 100, so your vertical slope rising 1. So here answer will be 108.0. Similar that up to 200, your answer will be 109. You already know, because 100 to 200 means 100 meter distance. So your answer will be 109. Now here, what is the value of at a 50-meter distance? So you know that at a 0 distance 107, at a 100 108. So your answer will be 107.5, and up to in a 150, you know that 108.5. Okay, you have clearly understand, you are thinking in a logically form, because your rising gradient is 1 in 100. So you have start from 0 to 100, so 1 meter rising the gradient. So at a 50 meter how much? So is 107.5. Similar that here 108.5. Now easily, now you have find the ground level and formation level. Your work will be start at a formation level. So you have filling this particular portion. So you have find different height. So how to find the height? So you know that at a distance 0, 50, 100, 150, 200, ground level is given. FL you are already find. So you have consider formation level minus ground level. So getting the value of filling means H, because our equation is B plus HS. So what is the value of H? So H at 0 distance is 2.20, because you have subtract them. 107 minus 104.8, 107.5 minus 106.2. So you're getting the answer of small h, and put the value of particular this equation. So now you know that area B plus SS into H. B is given, slide slope is given 2. Already in an example here, wait 1 minute. S equal to 2 is given, and B is 12 meter is given. So here 12 plus 2 into H. H you are already find 2.20 first. So area is getting 36.08 meter square. Similar that you have find the area 2, area 3, area 4 and area 5. And after the getting the A1 to A5, then you have put the equation in a Prismodial formula, because asking in an example only volume according to find the Prismodial formula. So V equal to D by 3, A1 plus A5 means first cross section area plus last cross section area, plus 4 in bracket sum of even cross section area, plus 2 in bracket sum of odd cross section area. So getting the answer is V equal to 3505 meter cube. So this is our example, most important example. First I have repeat this example. First you have writing the which data is given, then draw the figure. So you have clearly understand. First this is a ground level. Ground level RL is given, reduced level is given. Then you have one formation level is given. Then one rising the gradient 1 in 100. So you have find the other formation level, then making the table and try to find the depth of filling, and then find the area and put this area in a Prismodial formula. So you're getting the answer of particular Prismodial volume of the particular embankment, highway embankment. So this is an example to find out the filling of the highway embankment, volume of the highway embankment. Now I have explained capacity of reservoir. So how to find the capacity of reservoir? So the plant containing any contour represent a horizontal plane and the area bounded by a contour is treated as the area of cross section. So when you have find the capacity of reservoir, you have uh, make the or this area is volume or area is represented by the contour map. So here using the contour map, this type of map is contour map you have already studied in a basic civil engineering subject. So based on this contour map, so you find the capacity of the reservoir. So a contour map is a very useful to study the possible location of reservoir and the volume of water to be confined. So here you have find the capacity of reservoir. These are not our syllabus. Means theory is not our syllabus, but I have just for a reference. So you are not getting in a detail. So you have directly find the example of capacity of the reservoir. So the area enclosed by the contouring reservoir are as follow as a contour. Contour is given, interval is given 175, 180, 185, 190, 195. At every 5 meter distance interval, getting the area is given, directly area is given 460, 750, 2500, 3500 and 3950. So you are directly find the volume by trapezoidal formula and prismodial formula. So the top of the level is 195 and the lowest point is a 175. Top is a 195 and lowest is a 175. So find the volume means reservoir capacity between 175 to 195. So find the trapezoidal formula and prismodial formula. Contour level, you know that the difference is 5 meter. So directly you are using the formula volume according to the trapezoidal formula V equal to D by 2, first area plus last cross section area. First is a 460, last is a 3950 plus 2 in bracket sum of remaining area. So volume is 44775 meter cube. So here you have say that volume of water means capacity of reservoir is 44775 meter cube. Similar that volume according to the prismodial formula. You know that formula D by 3 first area plus last area plus 4 in bracket sum of even cross section area plus 2 in bracket sum of odd cross section area. So put the value of all the area and getting the answer of V. So you know that I have already explained volume according to the prismodial formula is given the answer accurately. So you have considered the volume of capacity is 44016.66 meter cube. So this is an example to how to find the capacity of the reservoir. Now second example, you are just for a exercise only one step added. Same example of the previous example. First contour level is given, area is given, find the area from trapezoid, volume from trapezoidal and prismodial. So interval is 2 meter. So first using the formula, you know that trapezoidal formula and then using the prismodial formula. But here in a asking in an example also compute the prismodial correction. So after the finding the volume according to trapezoidal formula and prismodial formula, I have already explained what is a equation of prismodial correction. It is the volume according to the trapezoidal formula minus volume according to the prismodial formula. So you have 651138 you are getting from the according to the trapezoidal formula and minus volume according to the prismodial formula. So answer is 4548108 meter cube. So subtract them. So answer will be 103030 meter cube. So in a previous example, you have only find the volume, but in a last example, means this example, you have find the another component is a prismodial correction. So same, you have first find the trapezoidal formula, volume according to the trapezoidal formula, then volume according to the prismodial formula, and then subtract them. So you will get the answer of prismodial correction. So thank you so much for watching this video. Student, in this video, I have explained about one example of how to find the depth of filling of highway embankment as well as the volume of the highway embankment. And then I have explained about the capacity of the reservoir, and I have taken two examples based on capacity of the reservoir. So thank you so much for watching this video.